All right, welcome to KBOCC Chapter 9 for the Earth History class. This is Weathering Soils. This is part 2. If you'll make sure to watch part 1 beforehand. I wanted to do this in 2 parts to make sure I had enough time to cover the final little bit about soil erosion in enough depth so that you, my wonderful students, don't feel like I'm rushing you. All right, so let's get into it. Soil erosion. We've talked a bit about weathering so far, but I've kind of sprinkled erosion sometimes here and there. And at this point, I want to make a distinction between the two. Weathering is the destruction of the material, and erosion is the movement of the material. In practice, the two are always happening together, but they are distinct, separate mechanisms. Breaking a rock and moving the parts that you broke are different processes, right? They're always combined. The water that hits the raindrops that hit the rock and bust it up also move the rock parts. But, and if you say weathering and erosion, if you mix the two up in casual conversation, no one's going to obviously care, right? But I want to make sure to emphasize why soil erosion is separate from soil weathering. Because you don't really weather soil, but you don't weather dirt. Dirt and soil are the result of the weathering, and then the movement of those is the erosional process. Cool. So soil forms very slowly and is often depleted faster than it is formed. It is formed slowly because you got to break down the material to get it to be laid down, and it's depleted quickly because it's either used up, the parts the plants need, for example, are used up, or it's just loose and it moves with the wind and the rain and stuff like that. Soil erosion rates, of course, affected by climate factors such as wind and water and land use, right? We're moving soil all the time for construction purposes. You're digging up and tossing soil every which way for farming purposes. People go to the gardening store to buy bags of soil for a reason. Erosion of soil by wind and water occur when, again, those particles become detached from the soil column and can move around. Dust floating in the air is soil erosion. It's taking rock particulate and it's putting it in different locations. The more vegetation cover you have, the less like this is going to happen, but it'll still happen. The higher the rain, the heavier the raindrops in the soil, the more they're busting up, the more they're moving around, right? Slope, obvious. We talked about a lot of these things in the mass wasting chapter a few chapters ago. This is the same sort of conversation we're having here. So again, right, I just use that as an example. When the water hits the soil, it splashes a bunch of soil up in the air. That soil is now free and more easy to move. Right, dust bowls, examples like that. I'm sure you've been to a beach on a windy day and been pelted in the face with sand, right? Same conversation. Of course, the very famous dust bowl around the Great Depression in the 1920s. This is actually a fantastic example of spot 4 here, vegetation coverage. Farming practices weren't as in-depth as they were 100 years ago. Weren't as in-depth now as they were 100 years ago. 100 years ago, there was less science behind farming. It was more throw stuff in the ground and watch it grow. So they planted lots and lots of crops that didn't do well in the particular soil, and they just kept planting them over and over and over again, and depleted that thick topsoil and turned it into a thin topsoil. Essentially turned a temperate soil profile into an arid soil profile, which means that the material is more likely to be shot up in the air. It's looser. So when violent storms come in, it's going to rip up entire masses of dirt and sand and throw it all around everywhere because there's nothing holding it down anymore. Dirt's not that heavy. Sand, soil's not that heavy. If it's not compacted down and collected together, it's liable to move. This is a massive erosional process. You're looking right there at a picture of erosion. Right? Rain dislodges it, wind dislodges it, what have you. In fact, if you look at modern farms, you can see there's all these little hills, all these valleys running through them, right? These are water channels, if you will, allow water to move in a way that's not going to affect the soil and the plants nearly as much, right? Modern agricultural science, it's a science for a reason, has figured out better ways to farm so that we are less affected by adverse weather conditions. You don't lose an entire decade of farming to one bad summer. There's the Dust Bowl that we were talking about before, that picture. All the stuff in that red there lost its soil. You don't grow plants in weathered bedrock. You grow it in soil, right? And then here we can look at pictures of dots representing erosion of 200,000 tons of soil due to water and rain. Noteworthy here, the blue, that's tracing down the Mississippi River and its tributaries, right? Water's the primary mover of a lot of geology because it's stronger, right? Wind will move it too, but water's the big one. All those blue dots in the center there, all the tributaries of the Mississippi River coming together and dumping stuff out into the Gulf of Mexico. Humans, of course, are a very important agent in this process, as I've discussed a few times already. Poor soil management causes these issues. And well, in America, with our mechanized farming and agricultural powerhouses, we've kind of figured out a good practice for how to grow and take care of our soil. Other parts of the world, in particular Africa there, don't have the same resources we have. So they're still growing soil the way they have been for hundreds of years. Sorry, still growing crops the way they have been for hundreds of years, which is plant it, watch it grow. And you get lower yields out of that. You're more susceptible to climate-related disasters, famine, stuff like that. It's an important issue that hopefully someone will figure out. Ooh, I'm sorry. I'm doing double duty here. There we go. So when you hear about famines in, say, Africa or Asian stuff like that, you got to remember America was doing that not too long ago. So, and as it says here, lower erosion rates, better farming techniques cause good agricultural practices. And it's still an issue though, because there's no perfect way to farm, right? You have tens of billions of dollars a year in soil erosion, economic losses in the US alone. So what is soil conservation? What is caring about your farmland so your crops can grow the most efficiently as efficiently as possible? Pictures like this, right? There's a reason farms are even oriented the way they are. And there's a reason why there's lines of crops rather than just big chunks of crops, right? There's reasons for all these things, and it all revolves around the science of agriculture. Some U.S. farmers are adopting no-till practices to prevent soil erosion. They leave harvest residue in the field and plants in between crops of previous harvests. So instead of digging up everything again and laying brand new soil on there, let the soil naturally grow the way it's supposed to. As we talked about a lot, the difference between soil and dirt is soil has those organics in it. Soil has the minerals and the nutrients that plants crave, right? So if you look at places where you're growing specific specialized agriculture, you're going to see that there's a lot of science. I'm going to keep saying that. You can see there's a lot of science. There's a lot of methodology. There's a lot of practicing and priming for what you're going to do. If you're not taking care of your soil, you're going to get famines. It's as simple as that. It happened all throughout human history. Science has finally found a way to combat that somewhat effectively. There you go, the soil conservation. And of course, we can go back to our concept map. We see what these at the end of every chapter. I talked about a whole lot of different stuff here, right? I talked about literally all four of the earthly spheres: apno, hydro, bio, and geo. in this conversation. Soil weathering and erosion are the small scale rotation of the earth. A large scale is your plate tectonics, your subduction, but on a day-to-day, week-to-week, month-to-month human scale, the changeover of our existence is directly a result of what we talked about here. There's your presentation. Part 2 was a lot shorter than part 1, but I'm glad I gave myself the extra 15 minutes or so to do it. So take care. Thanks for watching. Feel free to leave any questions or comments down below. Shoot me an email. And goodbye.